have some announcements. Okay, so sayang, hindi ko na-record yung ating introduction about the International Day of Mathematics. But again, for those who came in late, Happy Pi Day, the International Day of Mathematics 314. Okay. Um, so some announcements starting next week, next Monday, IMSP will be celebrating its anniversary as a National Center of Excellence. So meron tayong iba't ibang mga activities. So I think there were some flyers or pub mats posted in the Facebook group of the students and faculty of Math Division. So meron mga naka-line up na activities. So on Monday, I think we'll be having the student, alumni, and faculty conference, wherein we will have some speakers from the industry who will be sharing with us some of their experiences. And students are very much welcome to attend the festivities on Monday. So just to give you extra incentive to go, so I'll give you some bonus points. Probably siguro kasama natin sa kaya natin sasama. Sige, sama natin sa problem set number 1. Little bonuses. You just need to submit a short reaction paper. No format needed. No minimum number of pages. Just your honest and candid reaction or any realization or reflection you got from attending the event. So yeah, attend kayo. Tapos, yeah, bibigyan ko kayo ng konting bonus points sa problem set number 1. Not just on Monday, tapos may isa pa. So, sa 28, March 28, we'll be having research webinars wherein the research clusters of the division will be presenting our work. So, yon, attend din kayo. And then, probably I'll again ask you to write a reaction paper to get some bonus points out of it. So, ano pa nga ba? Yeah, doon naman siguro ang itatanong ko sa inyo. Bibigyan ko naman kayo ng guide questions para medyo magkaroon ng konting structure yung reaction papers. The SAF, yung Student Alumni Faculty Conference on Monday, siguro generic reflection or reaction paper lang. Yung sa research webinar on the 28th, I'll be asking you to identify probably 2 clusters that you got interested in their presentations. So probably yung isa ay inclined dun sa major nyo. Siyempre kung halimbawa actuarial science major kayo, siguradong interested kayo dun sa presentation ng FMAS. Pero I would be asking you to react or to say something about another research cluster para lang makita natin yung yung kakayahan natin to jump from one specialization to another. Kasi ngayon parang hindi na uso yung mga specialists. So basically we are trained to become interdisciplinary, cross-disciplinary. So yun yung gusto nating values na makuha. Okay? And then meron pang isa, first week of April. I just forgot what it is. Probably I'll just announce it later. Okay? Kasi 2 or 3 weeks from now pa naman yun. Kaya lang parang Holy Week or reading break na yung tatapatan niya. Okay? So those are our commercials. So kayo yung una nakarinig kasi kayo yung lab class ko, no? So pwede ba bukas pa-remind ako? One of you please remind me in case I forget to make these announcements to the entire lecture kasi lahat naman bibigyan natin ng opportunity to get the bonus points for attending the NCOE festivities. All right. Okay. So with those things out of the way, so let's talk about your problems, your laboratory exercise. So any questions or difficulties about it? Thank you dun sa ilan yung classmates. Meron silang mga na-discover na mali dun sa module. I'd been a little careless in writing my program for the secant method, and luckily, some of your classmates noticed some discrepancy. Actually, tama yung program ko pala. Hindi. May typo lang dun sa pagdi-display o pagpe-print out ng final output. Tapos, nabaligtad ko yung pag-i-input ng X0 and X1. So dun sa previous version ng module, yung ginamit ko sa presentation ay parang ang x sub 0 ay 1, ang x sub 1 dun sa secant method dapat ay 1.5. So kaya lang nung in-input ko siya dun sa aking sinulat na MATLAB code, ang x sub 1 ko, ang x sub 0 ko ay 1.5, tapos ang x sub 0 ko ay 1. So I also got good results, so that's why I was not very very what do you call this? Very doubtful or very skeptical about the result kasi alam kong magko-converge siya, and I got a very nice approximate for the root. Pero nung nag-try yung iba yung classmates to recreate the example, I think it's example 3.3, magkakaiba kami ng iterates. So kaya na-trace nila na may mali dun sa module. So thankfully natama ko naman siya over the weekend. Ayun, nakita ko nga baligtad yung pagkaka-input ko nung x sub 0 and x sub 1. And you see that inputting x sub 0 and x sub 1 created two different set of iterates. And that is understandable kasi dun sa first iteration, parehas kami. Kasi di ba yung x sub 0 and x sub 1, kukunin mo lang yung line passing through them, tapos yung x-intercept, yun yung next approximate, right? So it doesn't matter which one you call x sub 0 and x sub 1 from the point of view of the first iteration. Pero pag pumunta ka na sa second iteration, remember dun sa second iteration, gagamitin mo naman si x2 at saka si x1 dun sa secant method. So dun na magkakaroon ng pagbabago or pagkakaroon ng discrepancy dun sa iterates. Kasi ang nagamit ko dun sa maling pagka-input ko ng x sub 0 at x sub 1, ang nagamit ko sa iteration 2 ay si x sub, technically, ang nagamit ko ay si x sub 2 at saka si x sub 0. So hindi ko nagamit si x sub 2 saka si x sub 1. Kasi nga mali yung input ko ng x sub 0 at saka x sub 1. So that's a nice lesson na okay, pag nagkaiba ka ng starting condition, kahit pagbaliktarin mo lang yung dalawa, may iba yung sequence of approximates. But it doesn't matter kasi magko-converge naman siya to some number that is close to the actual root. Okay, that is if the secant method converges. Okay. And then nagkamali ako sa pag-print. Halimbawa natapos yung secant method na meet yung halting criterion, say at iteration 7. Ang na-print ko ay yung nasa iteration 6 kasi hindi ko na-update yung ipinapa-output ko na variable. Parang ang pina-output ko na variable ay guess, pero yung pinaka-updated pala ay yung variable C dun sa loob ng program ko. So yeah, some problems with my updating there. But I hope you got you were able to see the corrected version. So, and I think this is good. At least na double check niyo yung mga pinagsusulat ko. So mako-correct ko siya ng mas maaga before I compile them together into a work text which will be used hopefully for next offerings of Math 175. Okay, so yun lang siguro yung mga notes from me. Then the virtual floor is open for you guys for your questions about the homework or about the lab excerpt. May tanong ba kayo? Yes, Jeanette.
So sir, on the safe side po, bali yung pipiliin pong X1 ay yung mas malapit po siya sa convergent po kesa sa X sub 0?
Not necessarily. So actually hindi nagma-matter yung order. Kung parehas silang malapit dun sa root, kahit mas I think yung isa lang yung kailangan malapit. So kahit yung isa malayo. Pero kung sino yung pipiliin mo as x sub 0 at x sub 1, it doesn't matter. Kaya lang kailangan ko siyang i-correct yung nandun sa module kasi dun sa example 3.3, sinabi ko na si x sub 0 na gagamitan ay 1, tapos ang x sub 1 na gagamitan ay si 1.5. So yun yung ina-expect kong result. So nung ni-recreate ng mga classmates nyo, hindi nagtali kasi yun pala baliktad yung nagamit ko na x1 at saka x sub 0. But in a general sense, it doesn't matter. So kahit sino yung piliin yung x sub 0 at saka x sub 1. Okay.
Okay po, sir. Thank you po.
All right. You're welcome. Yes, Jonathan?
Good afternoon, sir. Ano yung akin pong question or clarification regarding po siya sa item 2, sir. Do'n po sa
Ah,
ano, do'n po sa ano, sir, sa fixed point, 'di ba po, guarantee naman po tayo na for any choice of x sub 0 magko-converge po siya sa P. Tapos po ang
mhm.
itatanong ko po sana, sir, ay kung kami po ba ang pipili ng x sub 0 or ilan po yung need naming ipakita sa sa output namin na pinili naming x sub 0? Like kahit isa lang po ba, sir, or need po na kagaya po nung module na nag-try po kayo ng iba't ibang starting point?
Okay, let me check kung ano yung sinabi sa exercise. Tingnan natin. Let's see. Hindi ko matandaan kasi kung ano yung okay, so dun sa 2A, define a convergent fixed point iteration at saka isang divergent one. So paglalaroan nyo lang yung equation na x minus r10x equals 1. And then implement a method. Yeah, kasi dun sa convergence analysis na gagawin nyo sa part A, mako-conclude nyo na yung isang fixed point iteration will converge for any choice of starting condition. All right? So sa part B, kasi pinapa-implement sa inyo to, kayo na yung bahalang pumili ng x sub 0. And since wala namang sinabi or walang number of iterations, number of um, implementations ang pinapagawa sa part B, so pwedeng isa lang. Pili ka lang ng isang x sub 0, then yeah, just run the iteration. And pwede mo siyang piliin kung gusto mo mabilis lang, pwede mong piliin malapit na siya dun sa solution na hinahanap mo. Or if you want to really verify yung convergence result na nagawa mo sa part 2A, piliin mo na malayo para makita mo lang, okay, mabagal siya mag-converge pero nag-converge naman. So it's up to you. And I encourage you guys to, though isa lang yung required, pwede nyo paglaruan. So para lang makita nyo talaga na nagko-converge siya. Kasi yun yung idea kung bakit dun sa modules, nilaro ko siya. Nag-try ako ng iba't ibang x sub 0 just to illustrate the fact that it will converge for any choice of initial condition, regardless kung malapit siya or malayo dun sa root. Tapos maganda nga yung isang example, di ba? Yung sa isang iteration doon, napakita natin na magko-converge yung fixed point iteration sa square root of 5. Kasi yung first derivative sa square root of 5 has magnitude less than 1. Pero pag ang pinlog-in mo naman ay negative root 5, kahit siya ay root nung actual initial equation na x squared minus 5 equals 0, na dahil yung first derivative ay mas malaki sa 1, kapag ka in-evaluate mo kay negative root 5, never siya magko-converge kay negative root 5. So kahit ang pinili ko noon na isang starting condition ay negative root 5, hindi siya magko-converge dun sa negative root 5. Kasi nga napakita natin by convergence analysis that it will only converge to one of those two roots, which namely square root of 5, at never siya magko-converge dun sa negative root 5, even if the initial condition is very, very close to negative root 5. Okay? So yun yung parang magandang idea rito na, okay, by a simple pen and paper analysis of the method, mapipredict mo na kagad kung saan siya magko-converge regardless kung saan ka magsimula. And actually, this is something that we do before we run a very big program. Siguro ngayon medyo isipin nyo pa, sir, hindi ko naman kailangan yon kasi isang hatak lang kay Excel, alam ko na kung saan siya pupunta or hindi. Why do I need the convergence analysis for? Maybe I'll just look for a fixed point iteration, i-implement siya kay Excel, pumili ako ng ilang mga test starting conditions. Pag meron ako 5 starting conditions, wala nag-converge sa kanila. So, ibig sabihin, divergent na siya. So, kailangan ko maghanap ng ibang fixed point iteration. So, you might be thinking of it that way, which is fine for small problems. Pero kung nasa isa ka ng malaking project, alright, meron ka isang malaking code that takes hours or days to run, na-experience ko to. Meron akong mga numerical simulations na kailangang iwan sa office for 2 days over the weekend bago ko makuha yung result. So I want to make sure na may ini-expect ako na solution after 2 days. Kasi pagka ang napili kong iteration, ang napili kong method ay hindi pala swak dun sa problem o yung initial condition ay hindi pala swak, edi masasayang yung 2 days. Tapos imi-meet ko na yung advisor ko, wala akong ma-present. Alright? So that's why convergence analysis is a very important aspect whenever running very large programs or codes. Okay? So yun, bahala na kayo. Pero isa lang yung hanapin namin. Pero try to play with it para makita niyo yung implications ng mga bagay-bagay. And you see the theorems in action. So yung mga theorems, hindi lang sila nandyan para pahirapan tayong mag-prove. So nandyan sila also to guarantee or to predict. Actually, hindi sila yung nagpe-predict to let us know what will happen. All right? So yung mga examples, yung actual implementation, they are just the instantiation o parang sila yung illustration, exemplification ng theorem. And usually yan yung hinahanap ng mga applied scientists o ng mga layman's. Kasi hindi naman nila naiintindihan yung mga theorems nating pinagsusulat. But if they see a picture, an illustration, a numerical simulation, then they are really convinced. All right? Na-experience ko yan. I am doing research na medyo engineering yung outputs, all right? Pero as a mathematics student, kailangan ko ng mga theorem. So magpo-prove kami ng mga theorem gamit yung functional analysis. So meron akong theorem 1, corollary 1, and so on and so forth. Pero kapag nagpasa kami ng paper to a journal for publication, yung reviewer's comment usually naka-sentro dun sa simulations. Nandun lagi yung mga tanong nila, yung mga clarifications nila, nandun yung comments. Lalo na kung engineering, medyo leaning yung journal. Hindi nila pinapakialaman yung theorem, hindi nila tinitingnan yung proof, kasi nga parang alien sa kanila yung nakasulat. Pero from my point of view, yun yung pinaka-pinaghirapan ko. Kasi pinuprove ko muna yung existence ng solution or pinuprove ko kung bakit ganito yung formula. Tapos pag nakakita sila ng exemplification na, oo nga, na-achieve niyo yung gusto niyang control effect via numerical simulation, okay na sila doon. Pero for us mathematicians, siguro pag nakakita lang tayo ng isang simulation o isang example, we'll say, baka naman nakachamba ka lang. So kaya kailangan natin yung proof, kailangan natin yung theorem. So, yeah. Medyo layo na nung narating mula dun sa question ni Jonathan. Pero I hope, Jonathan, that answers your question. There's a question in the chat from Francis. Sir, pwede po bang pa-explain po ulit ng asymptotic proportionality constant for item 2B? All right. So, yeah. Kaya lang baka madulas na naman ako ng masabi ko yung sagot. Pero, yeah. So essentially, yung asymptotic error constant ay ganito yung itsura. So to find the asymptotic error constant, lagi nang kakabit yung paghahanap ng rate of convergence. So you find the rate of convergence and the asymptotic proportionality constant by looking at the limit of p minus x sub n plus 1 over p minus x sub n raised to the power, or its absolute value raised to the power q as n approaches infinity, and you are praying that you find that constant q, which is the rate of convergence, so that this limit will be equal to a constant, say c. Right? So cq, okay, we want this c to be greater than 0, especially if q is greater than 1. Okay? So titingnan mo tong ratio, kailan yung p minus x sub n, naka-absolute value nga rin pala to. So basically, ito yung error sa n plus 1 iteration. Tapos ito yung error, yung base dito sa denominator. Yan yung absolute error sa nth iteration. Titingnan mo yung ratio. Pero merong partida dun sa ilalim. Yung ilalim dapat naka-raise sa isang power q or possibly naka-raise siya sa power q. You will be shopping for the smallest possible to the smallest ba. Or pwede mo siyang tingnan, pipili ka ng unang value ni q kung kailan ito ay magiging non-zero constant. Okay? Tingnan nga natin, kapag ka si Q ay mas malaki dun sa actual rate of convergence, so kung ito ay mas malaki, ibig sabihin mas malaki, ito ay maliit, so maliit raised sa malaki, mas maliit. Okay, so I think if your Q your guess for Q is larger than the actual rate of convergence, kindly double check me on this. Kapag ka yung Q na hula mo, kasi wala tayong formula sa paghanap ni Q eh. Pag yung Q na hula mo ay mas malaki dun sa actual rate of convergence, ang limit ay magiging infinity. Kung mas maliit si Q, yung hula mo kay Q para sa actual rate of convergence equal kay 0 yung makukuha mong limit. Or the other way around. I need to analyze it a little bit more para makita, right? Pero isa lang yun dun sa dalawa. So pag mas maliit, either 0 or positive infinity. Pag mas malaki yung hula mo, it's either 0 or positive infinity. Isa dun sa dalawa, alright? Magbabaligtaran lang sila if ever. So you are looking for the right value of Q that will make this limit equal to a constant. So si Q, siya yung tinatawag natin na rate of convergence. But other books might call this the order of convergence. So ang tawag natin sa notes sa kanya ay rate of convergence. Tapos si C, yung asymptotic error constant. Alright? So ito yung general definition ng rate of convergence at saka asymptotic error constant. Now, kapag alam mo na yung rate of convergence, edi madali lang mahanap yung asymptotic error constant. So kung alam mo na si Q, edi computein mo lang itong limit na to. Kung ano yung limit na yon, yun yung asymptotic error constant. So for the case of 2b, since that is a fixed point iteration, and we know that in the general sense, fixed point iterations converge with a linear order, so equal siya kay 1 sa case ng fixed point iterations. All right? So kunin mo lang yung ratio between two consecutive absolute errors. Okay? So si C, yung asymptotic error constant. However, we will have some difficulty still in computing this, especially if we don't know what the actual fixed point P is. Kung ipina-analyze ko yung fixed point iteration examples ko sa klase, madali lang. Kasi alam natin si Pi square root of 5. Siya yung limit. Okay? Siya yung limit. Siya yung actual fixed point. So masasubstitute nyo yung value ni P. Unfortunately for you guys, you don't know what the exact value of P is in problem 2b. Kasi kahit i-graph nyo siya, makikita nyo lang 1 point something yung, tama nga ba? Nasa 1 point something yung solution ng equation. So yun yung hanapin yung fixed point, yung solution ng equation. Now, syempre, hindi nyo siya masasubstitute dito. So we cannot compute for this limit because actually the problem 2b is a nice example of the usual thing that you will see in the practical world. Hindi mo alam yung actual P. So kailangan natin mag-isip ngayon, meron bang result yung nagsasabi sa akin ano yung asymptotic error constant? So punta ka sa module, tingnan mo, meron ba tayong result na nagsasabi paano computein yung asymptotic error constant? And you will say that probably there is because we already proved or we already seen that fixed point iterations converge linearly. So baka meron tayong result for that. Now, sige, browse natin yung notes. Corollary 3.1. Mukhang wala naman kasi yung corollary 3.1 useful siya sa convergence analysis para malaman kung magko-converge ba yung fixed point iteration or hindi. So, okay, wala tayong mapapala dyan as far as AEC is concerned. So, ano yung susunod? Oh, theorem 3.5, marami siyang laman. So, most probably we have something here, okay? Now, look at result number 3. So, remember, you're taking the limit sa AEC, dapat limit siya ng P minus xn plus 1 over limit ng P minus xn. N approaches infinity. Ito yung asymptotic error constant. All right? Now, okay. So ito yung problema ko. Hindi ko alam yung mga values niyan kasi hindi ko alam yung actual P. All right? Pero look at the equation 16. It gives us an estimate for P minus x sub n. So pwedeng siya yung gamitin mong pampalit kay P minus x sub n o kaya kay P minus x sub n plus 1. Right? Just change the indices. And you can use this nice expression over here. Though I won't suggest you use equation 16 if there is a better better result. Bakit hindi ko siya i-advise? Kasi ito ay bound. Bound siya dun sa absolute error. It's an absolute error bound, and we are not sure if this is tight. So alam lang natin, hindi lalampas yung error dito, which is a factor of the difference between the initial guess and the first iterate. So okay lang naman si lambda kasi si lambda yung max ng f prime over the interval AB. So kung wala na talagang ibang result, then go ahead. You can use this para ma-define yung numerator and denominator. Okay? And compute for the limit, okay, of that expression. Though, ano ba mangyari doon? Yeah, you will take the limit as n approaches infinity. Magkakaroon ka rito ng power n. So basically, I'm guessing that will involve a power of lambda. Okay? And lambda is the bound for f prime. So that's one way you can do it. Okay? Pero the better one is to use equation 17. Kasi tignan niyo yung forma ng example ng equation 17. Limit na siya ng p minus x sub n plus 1 all over p minus x sub n. Exactly what we need except for the absolute value bars. So lagay mo yung absolute value bars dyan. Lagay mo rin to ng absolute value bars dyan. And then, yung pala, makikita mo na, ito yung definition ng asymptotic error constant because we know that the fixed point iterations converge linearly. Okay? At equal daw siya. Look at this guy. Equality pa siya. So, hindi ko siya kailangang less than. Hindi siya approximately. Pero in the long run daw, yung ratio ng errors ay mag-approach or magiging equal kay f prime of p, which is exactly what we need. And that would be, or the absolute value of that would be the asymptotic error constant. But again, you will have a problem here. Okay? Ang problema nyo ngayon, sir, sige, equation 17 is nice, pero it will require me to get the absolute value of the first derivative evaluated at p. Right? Sir, hindi ko nga alam si p from the, at the start, right? So, hindi natin alam si p. Pero, thanks to the convergence analysis you did in problem 2a, sure ka na yung fixed point iteration, okay, na dinefine mo, na nirun mo, ay magko-converge. And what you get as a result after matapos yung iteration, pag na-meet yung stopping criterion, you'll get an x star. Okay? Diba? Meron ka x0, x1, x2, x3, hanggang makakarating kay x star, which is your last iterate after the stopping criterion was met. And x star is our estimate for p. Tama? Alright. So, ibig sabihin, yung x star mong na-compute ay isang good approximation to p because number one, the fixed point iteration you used was already proven to converge by your work in 2a. And then, na-satisfy niyo yung stopping criterion. So, this is one good estimate kasi nga hindi na ganun kalaki yung nagiging change from one estimate to the next. Kasi ano nga ba yung stopping criterion natin? Jump criterion na 10 to the minus 6. So ibig sabihin, napakaliit na nung nagiging step every after iteration that they are insignificant with respect to the epsilon I gave you. So basically, you are now convinced that x star is a very good approximate to p. So sige sir, so instead pala na f prime of p, okay, kaya ko pala yung i-approximate or kaya ko nga ba yung i-approximate question mark ng f prime of x star. Okay? Kasi p is a good estimate for x star. However, we are not yet sure if f prime of x star is a good estimate to f prime of p, even though we already know that x star is a good estimate for p. Yun yung question. Alright? Pero thankfully, part ng assumptions ng contraction mapping theorem, yung continuity ng first derivative. Tandaan niyo yung definition of continuity. For every epsilon greater than 0, there exists a delta greater than 0 such that if two x values vary by delta units, then their y values or their function values will only differ by epsilon units. So yung continuity ng isang function guarantees na kapag ka magkalapit yung x values, yung y values nila magkalapit din. And here we are sure that f prime is continuous. So ibig sabihin, pag nag-plug in ka ng dalawang numbers na magkalapit, alright, kay f prime, yung function values na makukuha mo ay magkalapit din. Yun yung ibig sabihin ng continuity. And since we know from the work in 2A that P is very close to X star, then we can expect that F prime of P is very close to F prime of X star. So basically, you can justify na, yeah, F prime of the final estimate that I got by running my iteration would be a good estimate to F prime of P, which is exactly equal to the asymptotic error constant as mandated by the contraction mapping theorem. Okay? So yun, ini-spoil ko na yung gagawin nyo sa lab Exer, but I hope that is clear. Kahit hindi ako nadulas doon, talagang gusto ko siyang i-discuss. Somebody brought it up, so it was a good thing. And I wanted to discuss it, not just for the computational aspect, pero maganda kasi yung pagkakagamit ng mga assumptions ng contraction mapping theorem. And the different subtleties na nakita nyo ron na, okay, kahit magandang approximate si X star, kahit ito ay magandang approximation, pero pag pinlog in ko nga ba sila dun sa derivative, sure ba ako na maganda pa rin yung approximation. Alright? So it is usually a mistake among scientists or among students, kahit math or applied math na parang pagka nakakuha ng good approximate, parang iniisip natin maganda na siya kapag yung function values nila ay laging magiging magkalapit sa isa't isa. But that is not the case. Dapat continuous yung function kung saan mo sila pina-plug in. All right? So I want you to get those little tiny details, even tiny sila pero significant sila when you do actual research work and you're working with thousands or millions of data points, nagma-matter sila. And siguro that's one thing that I want to introduce probably in one or two topics in 175. Ano yung nangyayari pag ill-conditioned yung problem? Kapag kasi evaluation ng mga continuous functions, hindi sila ganun ka-unstable. Sila yung mga stable operations na pag nag-plug in ka ng dalawa magkalapit na numbers pa rin yung sagot. Pero may mga problems or may mga operations na pagka ginamit mo as input ay dalawang magkalapit na number, yung outputs posibleng magkaiba. So yung tinatawag natin na unstable systems. And usually sa tunay na buhay, yung mga systems ay unstable talaga. Alright? So kaya kailangan mong dumaan ng mga regularization procedures, lalo na pag sa inverse problems, saka sa mga inverse modeling problems. So gusto mong makita or gusto mong mas stabilized muna yung system bago ka gumawa ng computations. Kasi pag nagkamali ka lang ng konti sa input ng data or na kamalas-malasan, napaka-sensitive ng problem na hindi pala enough yung degree of precision ng computing software na ginagamit mo, crappy yung makukuha mong result. So, may mga ganun tipo. So, hopefully we can encounter those topics in 175 in 2 or 3 weeks time. So, pagpunta natin sa linear systems, doon ko na lang siya i-introduce. Pero I hope that answers your question, Francis. Yeah, ganun yung idea ko kung paano kukunin yung asymptotic error constant. Okay, you're welcome, Francis. Yeah, I was thinking kung pwedeng gamitin yung equation 18. Pero yung equation 18 pala ay halos restatement lang nung limit problem, right? So sinabi lang niya lang na yung p minus x sub n plus 1, ang absolute value niya ay approximately equal sa product na ito. All right, other questions? Tapos na ba kayo sa problem set? Sa lab Exer? Mukhang madali lang naman siya, no? Kasi secant method, madali ba ang secant method? Yeah, I think madali lang yung secant method. Mas madali siya sa regular falsi kasi wala ka nang pipilian kung sino yung i-retain na isa, right? So laging yung previous two yung ginagamit. So kailangan nyo lang i-save yung two previous answers. Yung previous answer saka yung current answer to get the next answer. And then yung part 2A, nahirapan ba kayo paghanap ng fixed points? Ano nga ba yung function na binigay ko? X minus R10X equals 1. Hindi naman kayo nahihirapan. Alright, so mukhang hindi kayo nahihirapan. So sige, i-zip ko na yung bunganga ko. Baka mag-spill pa ako ng tea. So medyo natagalan maganap. But I hope, Francis, you got there. Oh, by the way, guys, tapos na ba ang reg? Di na ako updated sa deadlines. Okay, good. So, good, Francis. So, tapos na nga ba yung reg? Ongoing pang payment of fees. Kasi kailangan na namin mag-submit ng service record. So, kailangan ko na yung final number ng mga students sa klase. So, I'll submit my service record siguro mamaya. So, kung ilan yung students sa SAIS, yun na yung ipapasa ko later. So hopefully you are already done with registration, or at least your name is already in my is already in SAIS. So yun lang naman yung kailangan kong malaman. Ano pa ba? And then yeah, siguro after mamaya, pag na-finalize ko na siya, I can finalize my consultation hours as well. So I can announce it on Wednesday in the lecture. So yung aking regular consultation hours. Okay. What else? Plug P. All right. About module number 4. Hindi ko pa rin siya tapos. Sorry naman. I was a bit under the weather Thursday and Friday. Tapos weekend, may konti pang fever pero tinamad magtrabaho. So, di ko talaga siya nagalaw. Nag-work naman ako ng weekend. I started writing the proposal for the PhD in data science program. So UPLB is planning to offer a PhD by research in data science. So something that you might be interested in the future. So sinimulan ko isulat yung proposal. So baka hanapin ni Chancellor yung proposal within the week. So kaya kailangan ko siya talagang simulan. But hopefully by Wednesday morning, you will have number 4, and then we'll talk. We'll go through it all together or sabay-sabay na on the first lecture on Wednesday. But definitely during the lecture on Wednesday, we will have a module 4. Hindi pwedeng wala. All right. So yun. It will be about probably, I'm thinking kung isa na lang root finding technique yung i-discuss natin or dalawa pa, tapos next week ay mag-acceleration methods tayo. Pero inisip ko siguro sobrang dami na nating ginawa sa root finding. Ilang weeks na ba tayo? This is week number what? Week number 6 of the semester? So technically, nakaka-4 na linggo pa lang tayo kasi yung first 2 weeks ay wellness period. So we have 4. And then we have 3 chapters. Gusto ko yung 3 chapters ay equally divided among those. So we have 16 weeks, I guess, in the semester. Tanggal na doon yung 2 wellness weeks. So that means around 5. So inisip ko ay i-cut na siguro yung root finding. Tingnan natin, pag-isipan ko. Kasi ano pa ba yung kulang? Ano yung mga problema? Sorry. Ano yung problema ng mga current methods na hindi pa natin na-address? So yung kabagalan ng mga interval methods, medyo na-address na ng Newton-Raphson at saka nitong secant method. So medyo napabilis na siya to order golden ratio and quadratic order. Yung kahirapan ng paghanap ng x sub 0, medyo sa Newton-Raphson ay medyo na-address na ng fixed point iterations, alright? Kasi sa fixed point iterations, basta magko-converge yung iteration, laging it will do so for any choice of initial condition. Of course, within the neighborhood. Pero kasama na sa convergence analysis natin yung paghahanap ng large enough neighborhood. Yun yung kagandahan ng corollary 3.1. Nasabi niya na pag may nakita ka lang ng malaking interval, kung saan ka merong isang fixed point, alright? Sure ka na merong isang maliit na interval kung saan mag-hold yung contraction mapping theorem. Tapos ang sabi ng contraction mapping theorem, sa kahit anong initial condition, okay, magko-converge siya dun sa fixed point. So, yeah, medyo na-address na, compared to Newton-Raphson, na dapat yung pipiliin mong initial condition dapat malapit doon sa actual root. Kasi pag malayo, posibleng hindi siya mag-converge. Maliligaw siya ng daan, right? Dun sa Newton-Raphson. So, yeah, so na-address na natin yung problema naman na yon ng fixed point iteration. So I guess we are left with two problems. Una, lahat ng solutions na nakukuha natin so far ay mga real numbers, right? There are some functions or there are some scenarios wherein we are also interested in complex roots, especially if you're solving ordinary differential equations na halimbawa nag-Fourier transform ka, so kukunin mo dapat yung roots ng yung complex roots ng isang function. So hindi tayo nalilimit sa real numbers. Also in applications in engineering, in acoustics, in optics, ang hinahanap nila mga complex roots. And so far, all of our methods ay lagi lang nagto-talk about real roots. Even yung Newton-Raphson, yung premises niya, yung theorem natin for the Newton-Raphson, laging merong interval na kino-consider. And once na-limit tayo sa isang interval, naka-assume lagi doon na real number roots lang yung nako-consider o yung convergence lang towards a real root yung nag-guarantee ng isang sufficient condition. Now, to address that, we will talk about some methods that will also give us complex roots. And you will see that the idea is very simple, all right? At least dun sa ipapresent ko na method. So I'm thinking about either using Bairstow's method or Mueller's method. So, or both of them, all right? Pero isipin ko pa kung silang dalawa yung ipapresent ko, yun yung gagawin natin this week. Pero kung isa lang sa kanila, dun sa kabilang meeting naman, ang i-discuss ko naman ni acceleration methods. Ang problema kasi ay, okay, dito sa fixed point iteration, kahit anong initial condition, okay. Kaya lang mabagal siya, linear yung convergence. So bumalik na naman tayo dun sa problema natin with the bisection method na napakabagal ng convergence. Now, one remedy to that para mapabilis yung convergence ng fixed point iterations or any either iterative scheme, posibleng pabilisin pa yung Newton-Raphson, pabilisin pa yung secant method, pwede tayong gumamit ng acceleration methods. Yung mga acceleration methods parang siya yung Richardson extrapolation that we met in Math 174, wherein we are extrapolating using two previous estimates to get a better one. So para ma-push lang ng konti yung iteration process para mapabilis siya ng konti para kahit na sige nasolusyonan nga natin yung problema ng paghahanap ng initial condition pero ang laki ng kabayaran. Ang kabayaran ay isang order o isang one rate of convergence, right? So kasi from Newton-Raphson quadratic, pag nag-fixed point iteration ka na hindi mo kailangan mag-worry about the initial condition, linear na lang yung nagiging convergence. So ang laki nung nabawas na convergence. So if you can't really use Newton-Raphson and you're forced to use a fixed point iteration, siguro meron tayong pwedeng magawa na extrapolation procedure to speed up the convergence of the fixed point iteration. Okay? And we have two candidates na pwede natin pag-usapan, yung Stephenson's method o kaya yung Aitken's acceleration process. So either pag-usapan natin yung lahat ng apat na yon, Mueller, Bairstow, Stephenson, and Aitken's, or pipili lang ako ng isang isang method para sa pagkuha ng complex roots at saka isang method para sa acceleration. Para tapos na tayo sa Unit 1 this week. Alright? And you know what that means if we finish Unit 1 this week, then problem set number 1 will be forthcoming. Alright? So I guess, tama ba? We have 3 problem sets. So expect a problem set probably next week or week after next. But definitely before we go to the reading break. Para wala na kayong problema during the reading break. Okay? So let me think about it and malalaman nyo by Wednesday kung ano yung naging verdict ko. Alright? So, but I hope that's okay. That's the immediate plan for the next couple of weeks. Alright, ang dami ko nang nasabi na out of the actual topic at hand. So do you guys want to say something? Questions? Clarifications? Or may gusto kayong i-share? Sure ba yan? Wala na kayong problema? Ready na ba kayo to submit Lab Exer 1.2? All right, I guess I'll take your silence as nadalian kayo sa Lab Exer 1.2. What do you think about the 175 Exers pala? Ako na nga pala ngayon yung sumusulat ng mga laboratory exercises. So, okay lang ba siya? Masyadong mahirap? Masyadong mahaba? I hope okay lang siya, doable within the time frame given. Because since every week nga meron kayong ginagawa sa 175, I was hoping that laboratory exercises can be fit in dun sa 1 to 4 p.m. nyo ng Monday. Anyway, you chose to enroll with the lab component. So, dun nyo talaga siya gagawin. So, Okay, so if there are no more questions, then I will close this meeting, all right? End the recording, close the meeting. Pero if you are still doing laboratory exercise 1.2 part B and you encounter any problem, I'll be online. I'll be available at least from 1 to 4 today hanggang 4 p.m. Kasi yun naman yung time slot natin. I'll just go to my office and magsulat ng konti. All right. I'll do some work on the side, pero I'm still online sa MS Teams. So kung merong questions or merong urgent concern, you can send me a chat. We'll try. Kung yung tanong niyo naman ay kayang sagutin via text or via chat, I'll reply right away. Kung hindi, I can call you via MS Teams as well. So para ma-discuss natin or gusto niyo ipakita yung program, bakit hindi siya gumagana, I can help you with that or I can try to help you with that. Kasi hindi nga ako sanay ng Python. I'm more of a MATLAB guy. But if you will still have some problems beyond that, I'll try to still answer you at the soonest. All right. I just need to run some errands probably around 6 p.m. and then have dinner at 7. But I'll try to reply as soon as I can. All right. Tapos hopefully, kung tapos na kayo tapos sure na kayo na wala na kayong papalitan, you can submit your work early. Siguro mamaya pag wala akong magawa ng mga around 7 or 8, simulan ko na rin yung pag-check ng lab exercise nyo, no? So para makomentan ko siya agad. So, yeah. But I'll try to finish grading it before we meet on Wednesday para meron na rin akong intro sa Wednesday lecture natin. All right? So, with that, wala na bang pahabol? All right, so if there are none, so I hope you guys enjoy doing Lab Exer 1.2 Part B. Enjoy the rest of the day, and let's see each other again on Wednesday. And until then, keep safe, everyone. And yeah, bye-bye.